Dear learners, welcome to our NPTEL course on Science Communication, Research Productivity and Data Analytics using open source software. Now, we are going to cover Bradford law of scattering. This law was formulated by Samuel C. Bradford in 1934. Bradford law basically describes the distribution of scientific productivity, particularly in context of journals. As in case of Lotka law, we saw that it was scientific productivity in the context of author, but in case of Bradford, he describes the scientific productivity in context of journals. This law is based on the observation that scientific literature in particular field is concentrated to a very specific number of journals. Those are known as core journals, and when we go further, then the number of scientific literature decreases. That means in any particular subject, there are some core journals which contribute the most of the growth of that particular subject, and most number of articles are concentrated in those core journals. The basic idea is that if you list the journals in decreasing order of the number of articles they contribute to a particular subject, then the distribution will follow a pattern, and this pattern is similar to geometric progression. If you see in geometric progression, let us see there is a term A, next term is AR, another term is AR square, then the difference, then AR divided by A is equal to R, AR square divided by AR is equal to R. That means the ratio of the succeeding term and the preceding term, the ratio of the succeeding term and preceding term is always constant. So this type of progression is followed in case of the journals also, if we arrange in order in the decreasing number of articles they contain. Let us consider the number of paper in a given subject that we expect to get after searching a collection of journals. By scanning the journal, we expect the most number of paper would be concentrated to a certain group of journal, and the relevant paper would have in the journals which are particularly dedicated to that particular subject. For example, a specialist journal in the given subject area will have the more article, followed by the journals which publish a few articles related to that subject area, and that followed by those journals which having occasionally published the article related to that particular area. Most of the journals will have no article related to that particular subject. But here the point is that we cannot do a random search, because random search won't result a fruitful conclusion. Hence, we want to prioritize our search, we want to do the search such a way that we get the maximum number of articles of that particular subject in minimum number of journals. Hence, first of all, we go through the journals or the pages of the journals which are dedicated to that particular subject, and after that we move to another journals. At the end of the exercise, we'll have the list of the papers which are related to that particular area. We'll have the complete list of the paper related to that particular area. Now, let us see, if you don't want to search broad number of journals, if you don't want to search large number of journals, if you want to decide that we may concentrate our search in some specialized journals, because searching a vast number of journals, searching a large number of journals would be time consuming and a costly affair. Then it's very important to know which are the journals which are relevant to that particular subject, because at the beginning of our search we don't have any idea about which are the journals having the maximum number of articles. Here the Bradford law play a very important role, and Bradford, given his contribution to find out those journals which are effective in that particular area of interest. Here the Bradford made a very important contribution and began the ranking of the journals in order to the number of articles found in them. The institutional procedure of searching can be facilitated by ranking of journal to their productivity. Here the productivity means how many relevant articles they contain. For example, let us see, if you are searching on a particular area, let us see artificial intelligence, use of artificial intelligence in library. We want to make the bibliography on that. Then we should know which are the journals which are contributing most to this particular field. In this case, Bradford law of scattering can play a very important role, and by using this law we can find out which are the journals which are most relevant for us, or which are the journals which gives us the maximum result. Bradford arranged all the journals in bibliography in descending order of productivity. When we talk about the descending order of productivity, that means he put that journal which having the maximum yield, that means which having the maximum number of published article, at rank 1, and then he came down accordingly. He took the journals which contain the largest number of articles and placed it at the top of the list and gave it at the first rank. Then the next journal would get the second rank, third rank, and so on. If it happens that the same number of articles are in two journals, for example, a journal contain 10 articles, another journal contain also 10 articles. That means if the two journals had the same rank, then the next journal would have the R plus 2 rank. That means if the same journal, if the two journals having rank R, let us see if the two journals having rank 20th, then the next journal would be the rank 22 instead of 21. That means the rank R of any journal indicate that there are R minus 1 journals which having the higher productivity. For example, if you have 25, at 25th rank we have a journal having the contribution of 18 article. At 26th rank we have journal contributing 16 articles. Again at 26th rank we have a journal contributing the same number of articles. Hence the next ranking would be 28th instead of 27th. That means the rank R of any journal indicate that there are R minus 1 journals which having the higher productivity. Means in case of 28th rank here, this indicates that there are 27 journals which having higher productivity or which having more article as compared to the journals which are put at 28th rank in this case. Now, having obtained the rank list of journals arranged in decreasing order of productivity, Bradford divided the list of journal into three parts, and those parts usually called zones, and each part contain approximately the same number of articles. That means what Bradford did? Bradford arranged the journals in descending order based on the number of articles they publish, and then he divided the journals into three zones or three parts, such that each part or each zone will have approximately the same number of articles. The first zone or the first part would be the most productive journal, and the next part would be the less productive journal, and the last part would have the least productive journals. In order to add the same number of articles, zone 2 will have the more number of journal as compared to zone 1, and zone 3 will have more number of journals as compared to zone 2. That means the main zone, which is zone 1, which is the most important zone for that particular subject area, is the nucleus basically. That is the core zone which contain the core journals which publishes the maximum number of articles pertaining to that particular field. When we move further, then we'll have the number of journals which are more in number but contain less number of articles. That means they are in zone 2 and zone 3. Bradford formulated his law after studying a bibliography of geophysics covering 1332 articles from 326 journals in the field of geophysics. He discovered that 9 journals contain 429 articles, 59 journals contain 499 articles, and 258 journals contain 404 articles. Based on the result what he obtained, he found that 9 journals contributed approximately one third of the article, because the total number of article is 1332. This divided by 3 is equal to 444. That means approximately 9 journals contributes 429 article, which is approximately one third of 1332. In next phase, he found that 9 into 5, that means 45, to produce the next one third. Here, in actual scenario, 59 journals produce 419 article, and the next 9 into 5 into 5, that means 225 journals produce the next one third, 404 article. Here 258 journals produce 404 articles. That means approximately what he concluded that one third of the article is produced by 9 journals, followed by one third produced by next 59 journals, and approximately one third produced by 258 journal, and there is a relationship between 9, 59 and 258. Based on that, he expressed his law of scattering in the following way. He said, if scientific journals are arranged in order of decreasing productivity of articles, we have seen what is the order of decreasing productivity of article. We are arranging the journals in descending order. That means the journals which are contributing maximum article would have at the first place, and so on. On a given subject, they may divided into a nucleus of periodicals or journals more particularly devoted to a subject, and several other group or zones containing the same number of articles as the nucleus. What Bradford is saying here, Bradford found that if we are arranging the journal in order of decreasing productivity of article on a particular subject, they may be divided as a nucleus and various other zones which having the same number of articles but the more number of journals. The number of journals of periodical in a nucleus and succeeding zone will be in the ratio of A n into n, because we have seen the geometrical progression. That means it would be like A is a nucleus, then after that it would be A into n, then it would be A n square, and if you dividing the succeeding term into the previous one, if you're dividing the successor to the predecessor, we'll get a constant ratio. For the example, if an divided by a, will getting a. If an square divided by an, we getting n. That means if an is divided by a, we are getting n. N square divided by an, we are getting n. That means this ratio is always fixed. The value of Bradford multiplier is not fixed, and it varies from one bibliography to another bibliography. What Bradford found that different bibliography having the different number of core journals and the journals which are related to that particular subject. Bradford law is often expressed in three zones. That means core journals, secondary journals, and tertiary journals. As the name indicates, the core journals are those journals where the most important and significant article in the field are published. They are always small in number, and this particular zone, that means core zone, contain a very high number of articles. Now the second zone, which having the larger number of journals, publish related article to that particular subject, and the third zone will have the larger number of journal as compared to zone 2, publish a very few article related to that particular subject. Garfield basically, when he studied the Bradford law, Garfield made a physical analogy of the situation described by Bradford, like it would be a cornet with a dense nucleus representing the core journals, maximum number of journal to that particular subject, and sparse parts representing the additional journals that sometimes publish material relevant to the field, and these are known as the peripheral. In Garfield analogy, we can say that zone 1 of Bradford is basically the cornet, which is very dense and publish the maximum number of articles related to that particular subject, that particular field, and the succeeding two fields, the succeeding two zones are basically the periphery journals which contain less number of articles which are sparse in nature, which are not dense. Let us understand the Bradford law with example. For example, if you want to compile the bibliography on a particular subject, you are getting 100 articles, and those 100 articles are published in 10 journals. The next 100 articles are published in 50 journals. Another next 100 article is published in 250 journals. As for the Bradford, this 50, there is a relationship between 10 and 50. 50 is equal to 10 into 5, 250 is equal to 10 into 5 into 5. That means if we are taking as 5 as n, so this is 10 into n, this is 10 into n into n. If you divide 10 into n by preceding term 10, we are getting n, that means a ratio here, and if we divide 10 into n by 10n, which is the preceding term of this particular one, we are getting the ratio n here also. That means the ratio is constant. In this example, this is an ideal example. Usually this doesn't happen because I have explained this with a very simple example in which the number of articles are constant, the number of article is equal, 100 in all cases, and the journals are also varied in multiplication of 5 to the preceding term, but this usually doesn't happen in real scenario. Let us see in example 2, which is sometimes something real situation, which describes a real situation. We are compiling a bibliography on a particular subject, and we found that 18 journals publishes 125 articles on that particular subject. To get the same, approximately the same number of article, that means approximately the same number of article as 125, we found that it contains in 114 journals, and again approximately the same number of article we found that is contained in 753 journals. If you see the ideal relation, like in case of 114 journal, 114 divided by 18 is equal to 6.66. That means if you see as for the Bradford multiplier, it should be 18 into 6, but in actual it's 6.33. Similarly, in next Bradford multiplier would be 18 into 6 into 6, but it's approximately 18 into 6 into 7. So it happens because the actual number of journal varies, because when we are Compiling bibliography, approx number of journals we are calculating, and by that way we are finding the core journals which contain the maximum number of articles and the peripheral journal which contain the less number of articles. Now, what are the conditions for the Bradford law? Actually, for Bradford law to be implemented, Brooks suggests that there should be the strict conformity with Bradford law. Certain conditions have to be imposed on the bibliography. If we want to apply Bradford law, then there should be certain condition that should be applied on the bibliography. The first condition is that the subject bibliography must be well defined. It should be complete, that means all the relevant paper and serials must be limited, and bibliography must be of limited time span so that all contributing serial have the same opportunity of contributing paper. Hence, we are finding here the three important conditions laid down by Brooke for Bradford law. First, the bibliography should be well defined. The second, all the relevant papers should be included in the bibliography. It should be complete in all aspects. And the third, the time span should be defined so that all the journals, periodicals, and other technical paper should have the equal opportunity to be included in the bibliography. Now, we have covered what Bradford law is, what's the condition for the Bradford law. There are various applications of Bradford law. Now we are discussing the applications of Bradford law. The first very important application of Bradford law is the collection development in library. We know that libraries acquire different type of materials, and there is always requirement of fund, there is always crunch of budget. Hence, Bradford law can be applied for developing a good collection, because with the help of Bradford law we can come to know, a library professional can come to know, a librarian can come to know what are the core journals, what are the core publications which are relevant to a particular field, and only those publications can be acquired. Hence, Bradford law can be used for collection development. Another use of Bradford law is indexing and abstracting services can take the advantage of Bradford law in the development of good indexing and abstracting services, in the implementation of good indexing and abstracting services, because with the help of Bradford law, indexing and abstracting services can easily find out the core journals which are most productive in nature, and those can be included in their database for the providing of services. Another application of Bradford law is budgeting and funding decision. As we know that uh, academic institutions, many decision making bodies make budgetary decision, and Bradford law can be used for allocation of resources. By identifying the core journals, the resources can be allocated and optimally utilized. Another application of Bradford law is information filtering and recommendation services. When we talk about information filtering and recommendation services, that means with the help of Bradford law, this system can prioritize content from core journal, offering user more targeted and relevant recommendation based on the distribution of articles. We see there is flood of information, there is information explosion. It's very tough to get relevant information. It's very tough to give relevant information to the user. Now, Bradford law can help in information filtering and recommendation system, because based on the Bradford law, the system can prioritize the journals and recommend the information which are relevant to the user instead of recommending the information which are irrelevant or not relevant to the user. Bradford law can also be used for information retrieval by search engines. We know a good search engine gives good result. That means a search engine which gives the pinpointed result or the result which are required by the user is termed as a good search engine. One of the characteristics of good search engine, that means it has good precision, it gives the pinpointed information. Here the Bradford law can be applied for information retrieval by the search engine, because the search engine can make the ranking of the journals based on the information content to them in any particular field, and accordingly can provide the more relevant result to the users. Bradford law can also be used for research impact assessment. Based on the Bradford law, an institution can find out in which particular journals the researcher are publishing, a department is working with, and by that way the research can be evaluated and a department can assess the result of a researcher. Bradford law can be applied in information overload. We know that information explosion is everywhere. We are loaded with information. Here, to get the relevant information, the application of Bradford law is very important. By understanding the need of the researcher, by knowing the good quality of information, Bradford law can assist in understanding information overload. Bradford law can also be used for the research planning and strategic planning and research collaboration. Bradford law can be used for strategic planning and research collaboration. By studying Bradford law, we can find out the core journals of a particular subject. Researcher in that particular subject can collaborate with the scholars, the people who are publishing in those particular journals, and there would be a collaboration among the different institutions, collaboration among the researcher. There would be the development of a collaboration network. Bradford law can also be used for the literature review. As we know that literature review is a very important step for research. Bradford law can be used for the literature review because Bradford law gives the core journals which are relevant to a particular subject area, and a researcher, a scholar can use those journals first for the review of literature, because he or she knows that those core journals are the journals which having the maximum number of articles related to a particular subject. What are the limitations of Bradford law? Bradford law having some limitations. Although we know that Bradford law is very important law for collection development, for decision making, for fund allocation, but this is not a strict rule and may have variation in application depending upon the specific characteristics of different discipline and evolving pattern of scholarly communication. In the beginning of our lecture, in beginning of my lecture, I have explained that how science communication is evolving. Science communication is dynamic in nature. So Bradford law is basically not a strict rule that should be followed. Since science is evolving, science is dynamic, science communication is dynamic, hence, and there are different aspects of science, there are different disciplines of science which are ever growing, ever increasing. Hence, the Bradford law having some limitation in applying as a rule of thumb to every subject area, every discipline of science. Thanks for your patience hearing. Thank you.